Ontario Tech Engineering Outreach Presence, thriving in the age of artificial intelligence, developed by Ontario Tech Engineering and Applied Science. Engineering Outreach, with support from University of Guelph and Ryerson University.
Hey everyone! I hope that you had fun learning about machine learning and deep learning in Module 2. In this module, we're going to learn about how AI is used to accomplish previously difficult tasks and how companies and businesses are taking advantage of this to grow. Now that we understand what AI is and its relationship to machine learning and deep learning, it should be easier to understand how AI is applied today. Let's first look into some examples of how companies are using AI to develop more efficient businesses. A lot of companies you see today are either directly involved in or reliant on the manufacturing sector.
An image of some robots working in a production line shows up on the screen.
In terms of a factory, there are a lot of potential problems when it comes to running a production line. This can be anywhere from a part defect, a faulty piece of equipment, or a process on the line that is reducing its overall efficiency. Unfortunately, this can lead to millions of dollars of loss for the company, so this is where AI can come in to help. Through the use of AI and anomaly detection, companies are well equipped to find these outliers, classify the impact, and optimize the rate of production. Machine vision is a specialization of AI that can be used for the same purpose. It involves cameras, sensors, proper lighting conditions, and complex algorithms to create a system that will allow the computer to see and make quick decisions. During product assembly, machine vision is used for identification, positioning, measurement, verification, as well as flaw or anomaly detection. These processes combined contribute to the automation of visual inspection and precise handling of equipment and assembly parts. With proper staging, a conveyor belt or robot would be able to hold a part still for a short period of time so that a camera could take pictures.
An image of a red apple shows up on the screen.
These images are then converted into an array of pixel values.
The red apple image is converted to a pixelated image on the screen,
Compared with other test images, then digitally analyzed by the computer to see if everything looks good. Now you might be asking yourself, well, how does anomaly detection work? In data analysis, anomaly detection is the identification of rare items or events that differ significantly from the majority of the data. To understand this in more detail, let's take another example. Imagine that you're buying a dozen donuts, which are each $1. However, when you go to scan them at checkout, one of them scans for $2 instead of $1. This would be an anomaly, as the price for the same kind of donut is different than the majority of the other donuts. By using AI and these data analysis tools, we can help government agencies, manufacturing companies, and banks spot anomalies that are indicative of waste, inefficiency, fraud, and abuse. Now, there are a lot of different algorithms that we can use to detect anomalies. However, in this module, we're only going to be covering 2 of them. The first type of algorithm is density-based. In this type of anomaly detection, we look at the neighborhood of the point, which is defined by a given radius. An object is then considered an anomaly if its neighborhood does not contain enough points. Looking back at the donut example, we can use the price of the donut as the data and plot the price of the donuts on the graph shown here.
In this graph, we can see some points which are in the vicinity of each other on the right, which are the $1 donuts, and one point can be seen on the left, which is the $2 donut, and it is far away from all the points.
In order to use the density-based algorithm, we need to look at the neighborhood of each point. After doing that, we can see that the $2 donut is not surrounded by any neighboring donuts in our data. Thus, we can say that using the density-based algorithm, that this can be classified as an anomaly. The second type is a distance-based algorithm in which we look at the distance between the points in our data. However, this does have some disadvantages. To understand this algorithm, we need to go over a few key terms. First, we'll talk about clusters, which are just collections of data points. We also talk about outliers, which usually refer to any points that differ from the majority of the data, or in other words, are simply anomalies in the data. Let's look at another graph.
In this graph, we can see 2 clusters of points, a cluster of dark blue points on the top left, and a cluster of orange points on the bottom right hand of the graph. Then we have 2 points which are purple and light blue that are in the middle, away from the 2 clusters.
For this example, if we were to use the distance-based anomaly detection, we would think that this whole cluster of orange points is an anomaly, as it is very far away from the cluster of dark blue points. However, that is not the right assumption to make, because it turns out the true anomalies are the purple and light blue points. If we know that the majority of the data will be around one cluster, then it is okay to use the distance-based algorithm. However, if the majority of the data is spread out into several clusters like the example shown here, then using the density-based algorithm would yield better results. In conclusion, it is important to think about your specific application in order to determine which anomaly detection method you should use. Another real-life example of where anomaly detection is used is to detect fraudulent bank transactions. Imagine that you're someone who lives in Toronto and uses your credit card daily, let's say an average of $50 per day. However, one day your account suddenly shows a purchase of $3,000 that was made somewhere in France. Since this purchase is an outlier in terms of your normal spending habits, an AI anomaly detection system would flag it as suspicious or a fraudulent transaction in order to get it analyzed. Now, let's explore another example of how AI is making businesses or companies more efficient and secure. I'm sure many of you might have been on the phone with a bank before, and you might have noticed that during the beginning of the call, you were made aware that the call will be recorded. Ever wonder what happens with the recorded calls? Well, they're not only used to determine the performance of their agents, but also to help avoid identity theft. Want to know how? Well, each time you call the bank, the recorded audio is saved and is used to train their voice recognition system using machine learning. Since each person has a different voice, the system will analyze these unique vocal qualities such as the pitch, density, duration, and dynamics of your voice and save these as a unique vocal biometric. The next time you call, the voice recognition software will use it to compare with the previous recordings of your voice and determine whether you're truly, well, you. If you are misrepresenting yourself, the system may be able to determine who you actually are. In the following content, you will be introduced to what a business model is and how companies like Netflix have developed into what they are today.